Now we're going to learn new rules and new algorithms. Uh, in Grasshopper, we usually start with either points or curve or surface. We also there's not necessarily need to uh, generate these items in Rhino. We can initially and without specifically connect Rhino to Grasshopper generate all these components in Grasshopper. In this session, we're going to learn more about surface. So I will tell you this. In Rhino, in order to generate surface in this toolbar, we have this option that has many options. The most simple uh, surface that we can generate is a rectangular plane corner to corner. So I'm going to create one. So as you can see, we have this surface. In order to change change different modes of Rhino, we can, for example, choose rendered in viewport, which this is, or shaded to see the solid surface. In Rhino, we can change, for example, I would like to uh, have curve out of this planar surface. So with rebuild, I can, when I type rebuild and select this, I can change the point counts and degree in Rhino in this surface. For example, now this has 10 points in, then we can have 10 points in U. Actually, basically, it has just two points in U and V, but we can change all of this. So by default, this point count in the degree is 1, which means that this surface cannot be curvature. So I change it to 3, and I change the point count to 4. If I increase this amounts a lot, working will be difficult. On the other hand, if it's less than standard amount, uh, it's not, for me, it doesn't work. So uh, 4 in point count and 3 in degree will be alright in this stage. So I click OK. When I change it, doesn't necessarily means that this surface will convert to curve, but it means that when I turn on show objects control point, which is here, or just type show control points, control points in this and select this, it will show me the control points of this surface. Initially, it has just two in U and V, but now it has four in uh, U and three and three in V. Now, if I, for example, select these control points and change it, I can have this curve from this planar surface. But now I control Z this, and again I type rebuild for this, and I would like to for example, keep this amount 1, and then again select show control points. But now you can see that it's not curved anymore because of the degree is so sharp. But I can control Z the process, and again use rebuild and keep this amount 3 because I want this degree. And again show control objects. I select these ones. When you press shift and choose this, you can choose various points, control points. So I put this one away. I draw another surface with this. When you press shift, when you're going to generate a surface, you can generate a square rather than rectangular. So shift help this happen. And then I will connect this surface, set one surface to this, and I change the view to wireframe. And next I'm going to use the component of divide surface, which is here. Connect this to I can hide this surface in Rhino, but I cannot delete it because if I delete it I will lose the whole process. So I can hide it. Then I will use panel to specify the U count and V count, which means that in each direction what I'm going to divide, for example 20, and I both connect them to the U count and V count. When you press shift and connect this, it can connect it to both of this. So because this surface is square and the U count and V count is the same amount, you can see that all these distance between these points is the same because it's square and it is divided the same. And also I'm going to hide this. I'm going to use to generate circle and then connect this. As you can see, the wire in here is not continuous, it's uncontinued. This is because we have data branches. Actually, this surface is divided in 20, uh, divided by 20 counts, which means that we have 21 segments. What does it mean? For example, when I have a rectangular, when I have a surface, when I divided it in two, it means that we have three segments. So because we have divided this surface in 20, which means that we have 21 segments. So again, we have divided it in two, which means we have two segments, but we have 3 points. So in this place also we have 20 segments, but we have 21 points. So the number of points is always one more than the number of segments. And this dashed line that you can see here is because we have data branches. What does it mean? It means that um, each of these points are in one branch. So we have 21 branches, which means that we have 21 rows, that in each of these rows we have 21 points. So for example, when we use param viewer, which is here, it looks like a tree. It shows these branches, data with 21 branches, and the number of branches, number of points in each branch is 21. But now, uh, about these branches and data matching, we will talk later. But at this stage, uh, I don't want to have these branches, which means I don't want to go to 21 in this branch and then resort to another branch. In previous in our previous video, we talked about um, point list. So when I connect this, and for example, turn the preview of this and the size of 2, you can see that these branches. It started with 0, go to 20, 0 to 20, which means we have 21 points and 21 branches, which in this algorithm it's not useful, and for me it doesn't work for me. So what should I do is we're going to flatten it. For example, if we use polyline and connect this, and you can see that it has drawn 21 lines, but I will flatten points in the output. When you right click in each of these uh, parts, it has different meanings. The thing that I'm going to flatten these points. When I right click and select flatten, this branches will actually will convert to another way. It means that we have only one branch rather than 21 branch, which has 441 points, as you can see above the polyline. And if I enable the preview, we can see that it started with 0 and it ends with 440. There's no other separate branches. We will later talk about these branches, but now we have just one branch with 441 points. So I'm going to delete this and um, in this points I'm going to select just specific points. In order to do this, we have a component. This component that we're going to use is list item. For example, I have a plan. I have a panel, excuse me, with multiple datas in it. For example, 1, 5, 0, 4, again 6, and OK. As you can remember in previous videos, when we right click on panel and change it to multi-line data, when we select this and then connect this to the list, and then about index, for example, I want an index between 0 and 4 because the number is 1, 2, 1, 2, 3, 4, and then generate a number slider between 1 and 0 and connect this. And then another panel to see what's going on. So as you can see, when I have 0, the output item is 1. When I have 1, the item is 5, 2, 0, 3, 4, and 4, 6. So based on the index, you can see what is the amount, what is the item. This is list item. This is a list. So the purpose of using list item for me is that I want these circles um, to be tangent. In order to find out the radius, I will select 2 points and then understand the distance between these 2 points, and then half the amount to reach the amount of radius. For this, I'm going to use list item to choose 2 points out of this 441 points. Before decide how to use list item in this algorithm, I should add something that the list item has another option with insert parameter. This one item and adds -1, and for example this one is +1. I can has I can have another uh, options, other items, but now I would like to keep it on just -1. And so in that situation, for example, based on the index that I input in list item, for example the index number 3, I want the output at -1. So the process is like this, that it's um, consider the index number 3, and then the list item -1 is index 2. So the item and the amount of index 2 is 0, which is shown in this. Or for example, the index of 3, the item for +1 is index 4, and the amount for index 4 is 6. Or for example, if I change the index to 0, what will be the item of 0, 1? It will be again go back to index 4, so the amount will be 6. Now I'm going to use this list item in our algorithm. In order to do that, again, list item, I'm going to choose 2 points. There's no difference if I choose minus plus or +1, -1 or +1. I just want to select 2 points out of this flattened points, and the index of 0, it's better to use +1 because I don't want to have selected this point and this point, but just these 2 points. So list item helped us to choose 2 points. Now I'm going to use another component, distance, which is this one. It wants from me 2 points, this point and this point. And I'm going to use the output of distance to decide for radius. As you can see, in order to, I should have the amount of distance to reach tangent circle. So I right click in it, an expression, how x dash 2, commit changes, and tangent circles happen. So I will disable this preview but enable this surface. As you can see, this surface is smaller than this the area of this surface is smaller than the area of these surfaces. This surface actually is smaller than the amount of these circles. So I'm going to scale this surface to cover all these, the edge of all these circles. In order to use scale, I initially explain, for example, we have this circle and we have the component of curve in here. I'm going to set one curve and then this, and then component of scale, and the factor, for example, I would scale it in a half, so I use panel and this as factor, but this curve, this circle is scaled based on the coordinated point, which means 0, 0, 0, 0, which I don't like this happen. I would like to scale this curve based on its own surface, in its own center. Which is here, for example. But how in Grasshopper we can understand the center of this circle? In this situation, we have a component which called area. Area seems that has sub area properties, but uh, it is used also for recognizing the center of surfaces and curves. So the output of area is area of geometry. For example, the area of this curve is, if I use panel again, this is the area of this curve, but it has another output which is centroid. So when I use this centroid for as a center of this, it will scale the curve based on this center. For example, if I change it to 1.5, again it will scale based on its center. So this is what we means about centers and scaling, which is useful. I'm gonna save these algorithms in Google Drive so you can later watch this. And right now, as in AutoCAD, we have these magnets, we have these points that can help us through our drawings. You can select them and enable all of this. But let's get back to our own algorithm, which is this one. I'm going to use the component of area to decide this, the center of the surface. So my area, and the area should be for this, and I'm gonna scale it. I'm not sure I'm not sure that what is the exact amount of scale, but for example, I can use 1.2. It's not enough. For example, 1.05, which is great. Board, but I will use a bit higher amount to make sure that it covers all the circles. For example, 1.1, which is good. Now we're going back to this our previous surface. So for example, I did this and use generate another surface component and use set one surface, which is this. There's another component that we use is map to surface, this one. So in this situation, I'm gonna map these circles to this surface. Generally, it's really easier for us to um, generate algorithms on planar surfaces, but then project it on our desired surface. So for curves, we use these circles, which is here as curves, and the source of this scaled surface as source, and this surface as targets. I forgot to. You can easily disconnect these wires by press Control and then this, or press Shift. By pressing Shift, you can connect it. By pressing Control, you can disconnect. So you can see that I have projected these circles on this surface. Now I'm going to hide this surface and also disable viewpoint this, and you can see the circles on the surface. Then it's also, for example, somebody comes and say I would like to generate additional circles. As you can remember, when I'm going to copy the circle, simply just drag this and press Alt when you drag this, and you can make a copy of these circles. But this time, rather than have it in 2, I'm going to have divided in 3. So I have this circles also, and I'm going to map this. I'm going to use mapping these circles to this. So until this time we have this and for example delete this and this one. So I would like to unhide the surface that I generated. In order to do that, you can see this uh, when you left click it will be hide, and when you right click it will be visible. So I'm going to visible this surface. Then I will make a copy of this surface. In I will copy it exactly on itself, and then select one and choose the control points. No, it was the wrong surface that I scaled. I'm going to hide this one and going to hide this one and turn on these control points. And I would like to scale the bottom of this. So for example, when you draw a line from this point to this point, I can understand where is the midpoint, which is here, and then delete this. I will choose its control points by pressing shift and select all, not this one in the middle, and then scale it based on this point a bit inward and unhide the other surface. So I have two surfaces. So what I'm going to do is connect this surface to Grasshopper 2. So I will make a copy from this surface and set one surface, which is this one. And then hide both these surfaces, and I'm going to use this map to surface to target up this map to surface to this one. So these circles, the second circles that I generated, will be mapped on the second surface. Uh, but it become a bit messy because we scale the second surface. So I will control Z this surface and not actually rescale it. So it's better. We have uh, these two circles on two separate surfaces. What I'm going to do is connecting the upper circles to down its the down surface circles. In this step, in order to connect these two circles, it's really important to Grasshopper understand to not connect, for example, this circle to this one, or for example, this down circles to its adjacent circle. In order to solve this problem, we need uh, 3 branches, which means we need 441 branches, which contains 2 circles. For example, if we use Param Viewer, and again one for this, we'll understand that we have just one branch with 441 items, and again with this one. What I would like to have is exactly opposite of this. I want 441 branches with 2 circles to connect these 2 surfaces directly to each other. The components that we use here is Entwine. What Entwine do is creating branches. When I connect this to this one to this, and then use another Param Viewer, I can see that I have 2 branches, but it has made one branches with 441 items and the other one again with 441, which is not useful for us and doesn't work. But what we need is 441 branches with 2 items, because we want these two uh, perpendicular surface circles to be connected to each other. The component that we're going to use here is, because we exactly want to invert these branches and flip these branches, we can easily use flip matrix. Now if I connect these two and then use Param Viewer, I can see that I have 2 branches with just one item in it. Oh no, which is not correct. I mistakenly connected Param Viewer. I should connect this to this, not this. So I have uh, 441 branches with 2 items in it. This is the thing that works for us. Now I'm going to use the component loft, which we have the same in Rhino and AutoCAD, and then connect exactly these 2 circles to each other, because through this process we made 441 branches with 2 items that were connected via loft. If I now use the component of custom preview, and use white material and change it to rendered, in the center of the preview, you can see the result. Now I'm going to in Rhino type show, and I have this surface, and when I change it and then hide the surface, you can see the result will be changed easily. Again, for example, control points, and then hide it. Again, you will see the result is parametric and it will be changed easily. Or for example, if I again type show and select both of this and select some of these control points such as this, and changing, and again when you select the control points, the controls will be off, and then hide these two surfaces. You can again see that the direction will be changed, the height will be changed easily without any struggle. Again, we can, based on our creativity, we can change these surfaces, this on a free form easily and freely. So I'm going to save these algorithms in Google Drive. Please watch it and try it.